Hello and welcome to R&D Mathematics. Today we are going to talk about factoring polynomials. Factoring polynomials. Now, first technique, factoring by greatest common factor. So, greatest common factor. You can extract greatest common factor and factor it. So this is the easiest way. So let's see some examples. Let's say you have this polynomial 6x to the 5th minus 18x to the 4th. So this is the degree 5 polynomial. Now, when you look at this, look at the numbers 6 and 18. So I can pull 6 out. And 18x to the 4th. And look at the powers of x. X to the 5th and x to the 4th. I can pull x to the 4th out. Put a parenthesis here minus. So x to the 6, x to the 5th. When I pull 6x to the 4th out, I must have x. See, one way is you can always multiply these two and check whether that's this number. I mean this entity. Similarly, the next one is going to be I need 3 to make 18, and I've already pulled every possible x powers out, so that's it. Let's see more complicated example. 3x to the 5th minus 9x to the 4th plus 12x cubed minus 6x squared. Now something like this. Okay, look at the numbers 3, 9, 12, 6. So I can pull 3 out because 3 is a factor of all those numbers. And with the powers of x, what is the largest power that you can pull out? That's going to be the minimum power appearing in your polynomial. So x squared. When I pull x squared out, I need x. How many x's to make the first term? 3, right? Minus and 9, so I need 3 x to the 2 or x squared, and plus to make 12 with 3 I need 4 and x cubed, and I have already x squared, so I need x minus 2, and that's it. That's how you use greatest common factor to factor polynomials. Let's see one more example of different type. How about this? 6x cubed y cubed plus 45x squared y squared plus 21xy. Now in this case, this is a polynomial having multiple variables. Now in this case, x and y both are there. Look at the numbers 6, 45 and 21. Now you have to be good with multiplication tables, like can you pull 6 out? No. 45, 6 is even, 45 out, it doesn't work. I can pull 3 out. And about x and y, yes, I can pull. See, in the last term I have only one x and one y, so because of that I can only pull x and y out. So the first term, I need 6, so I need 2 here. X cubed, so I need x squared. I need y cubed, so I need y squared. Plus, to make 45 with 3, I need 15. X squared and y squared, so I need x and y because I already have x and y out there. With this, I just need 7. So 3xy times 2x squared y squared plus 15xy plus 7. Okay, so that's how you use greatest common factor. Now the next technique we are going to talk about using some factoring formulas. Now this is really important. Factoring formulas or formulae. Now, I'm going to give you three formulas. Now, let's talk about this. A plus B squared. This one is A squared plus 2AB plus B squared. Now, there is a common mistake that people do, students do. A plus B squared, A squared plus B squared. This is wrong. This is wrong. Don't do that, right? There is a middle term. Now, first, let me explain this to you a little bit. Now, first of all, A plus B squared is A plus B into A plus B, right? Now again, this is factors of A plus B squared. But once you remember this, you can easily apply it in problems. So that's why you need to remember it. But rather than trying to memorize it, it's better to understand. See, A into A, you get A squared. A into B, you get AB. B into A, you get BA. B into B, you get B squared. Now, AB and BA are the same, just the order is different. So, A squared plus 2AB, because these two are the same, two of them, 2AB plus B squared. That's how it comes, right? Now, let me show you one more thing. Let me show you one more trick. So, you will remember this forever. See, this power, we call it a square, right? There's a reason. See, I draw a square. And I'm going to partition it in such a way. So, this length is A. This length is B. This length is B. This length is A. Now, I have a question for you. First question, I want you to pause the video and think about it. This total length, first of all, what's that? That is A plus B, not AB, right? A plus B. Imagine A is 5 and B is 3. So 5 plus 3, it's 8. Like that, A plus B. And this length, same, right? A plus B. So the big figure here is a square. So the area of that big figure on one hand is A plus B squared, right? Because A plus B, the width, into A plus B, the length. So it's a square. Area is A plus B squared. But on the other hand, area is equal to these four areas. This area, this area, this area, and this area. Now tell me, what is the area of this part right here? This length is A, because here A, and this length is A. Because of that, that area is A squared. What is the area of this small part here? That is B and B, so B squared. And what is this area over here? That's A times B. And what is this area? A times B. So the area of the large figure equals to the sum of the area of these four rectangles, or these two squares and these two rectangles. So that's going to be A squared plus how many ABs? 1AB, 2AB plus B squared. See, this is a geometric proof for that formula. Now, for most of these formulas, there is a nice geometric way of interpreting it. Whenever the time is right, I will talk about those things. But anyway, let's go back to our factoring formulas. Now, this is the thing that you need to remember. Now, I explained it to you. Let's see some examples. So, x squared plus 6x plus 9. Now, in order to factor this, greatest common factor technique does not work because you don't see 1 is the only number you can pull out and it's going to give you the same thing. Now, with that factoring formula, if you are familiar with that, look at this last number, that's 9. So that's 3 squared. And remember that formula was A plus B squared. A squared, that means first term squared, plus 2 times AB, that 2 comes from outside, and 2 times AB plus B squared. Now, here x squared, 6x, pull a 2 out, can be written as 6 times 2, so 2 times 3x plus 3 squared. So it's clear this formula happened to be in this form. So this is x plus 3 squared. How about, let's say like this, 9x squared minus 12x plus 4. Now, if you are using this technique, one tip is, look at this number, okay, 2, and look at this number, 9. So here 4, here 9. So to get 4, I need 2 squared. To get 9, I need 3 squared. Sorry, 3x squared. And there is a minus sign, so minus squared. Now what you need to do, you need to check the middle term. It may be the case that middle term may not work. So for example, let's check this. So you can apply this and check it. So check it somewhere, in your rough work paper or somewhere. So 9x, 3x, everything squared. Remember that. That's what a squared means. So whatever your first term, everything squared. Minus, by the way, I forgot to tell you, if you have minus a minus b squared, this is same as a squared. Here you get minus sign. That's the only difference. I think you can work it out and see. Now, here 2ab, so that 2a is 3x and 2 plus 4. So you get 9x squared minus 2 into 2, 4, 12x plus 4, and that's correct. See? So for example, if you had 9x squared minus 10x plus 4, this does not work, right? So you have to check the middle term. Okay, sometimes remembering this is helpful. I mean, not sometimes, it's always helpful. Sometimes you can use this as a factor in guide. Especially in this course, you are going to factor trinomials. Mostly trinomials. That means things are in this form. There is a general way of doing that, and we are going to talk about that in our next video. But before we conclude, one more technique, one more formula. Now, a squared minus b squared. Difference between two squares. This is a plus b into a minus b. Again, this is something really helpful remembering. This appears again and again in many different applications, like when you rationalize denominators, this appears. In complex numbers with conjugate, this appears. And with factoring, this appears. Now let's see why this is true. See, a into a squared, a into minus ab, so minus ab, b into a, that's ab, or ba, plus b into minus b, so minus b squared. See, the middle two terms will cancel each other, and you get this. And a geometric proof. Can you think of one? Try to think of one. I'm not going to tell you. But anyway, now using this, let's see some examples. This is really helpful. X squared minus 9. So the factors are x. See, x squared minus 9 is x squared minus 3 squared. So it's in this form, a squared minus b squared form. So x minus 3 into x plus 3. Or the other way around, x plus 3 into x minus 3. It doesn't matter which order you put it. Now how about this, 4x squared minus 25. In this one, it's better to write down 4x squared is not, 2x everything squared. You have to identify that first. 5 squared. So your answer is 2x minus 5, 2x plus 5. How about this 16x squared y squared minus a to the 8, b to the 6th. Can you do that? It seems a little bit complicated with so many variables, but it's not. So first write it as a squared minus b squared form. So one term squared minus another entity squared. So 4xy, everything squared. That's how you get 16x squared y squared, right? Minus, now think about it. You know, you always can pause these videos and think, what should I write? A to the fourth, b to the what? Third, right? Now you see this guy here is a, this guy here is b in my equation. Don't get confused with two different b's. But so 4xy minus a to the fourth b cubed, 4xy plus a to the fourth b cubed, right? I think that is clear. And even this little nice formula is really cool. Let me, you know what, take your calculator. Let me think. Yeah, take your calculator and multiply these two numbers. What did you get? Let me show you how to multiply this quickly in your mind. A number like this. So 51 times 49. 51 is 50 plus 1, right? 41 is 50 minus 1. See, it's in this form. So I'm applying the reverse of this. So this should be 50 squared minus 1 squared. Now 50 squared, that's easy that you can do it in your mind. 2500 minus 1. 2499. See, there are tricks like this to do nice simple multiplications. I mean, difficult multiplications can be made easier using these kind of simple formulas. Okay guys, I think that's enough for today's video, and see you in next video with factoring trinomials. Thank you.